Now, in the series of classes on the special properties of triangle, which you might find useful in solving JEE Advanced problems or the IMO problems, another such property is the reflection of the orthocenter along the midpoint of a side. So we are not just simply reflecting along the side, we are reflecting along the midpoint of the side. So what does that mean? It means that let's say that this O is the midpoint of side BC, then if I extend this line HO by the same amount in the downward direction, I get to point Y, then this point Y would lie on the circumcircle of the triangle, which means that the circle which goes through A, B and C will also go through this point Y. Now, of course, the way I prove it is that I complete this quadrilateral BY and YC, and then I say that for this to be true, for this theorem to be true, ABYC has to be a cyclic quadrilateral. Now, if this is a cyclic quadrilateral, it means that the cyclic quadrilateral is cyclic if and only if the opposite angles, the sum of opposite angles is actually equal to 180 degrees. So, which means that this angle, which I am calling angle A, and this entire angle, which I am calling angle B, okay, this angle A plus angle B should be equal to, the sum of them should be equal to 180 degrees. So if I prove this, I prove that the quadrilateral is cyclic, and in turn I prove that the A, B, C and Y are on the same circle, which is the circumcircle. So how do I go about proving this? For this, the first thing I realize is, by definition, this BO and OC are equal. Also, by definition, HO and OY are equal, which means that these two diagonals of the quadrilateral BHCY, so I am looking at this quadrilateral BHCY, these two diagonals of the quadrilateral intersect each other, which means that this quadrilateral is a parallelogram, and that tells me that if this angle is B, this entire angle is also equal to B. Okay. So now I have to prove that my new B and my A are actually equal to 180 degrees. So what is the second step in doing this? I break these angles. So I say that this is 1 and this is 2, and then I break this angle also. I say this is 3 and this is 4. This is what I am saying. So now what can I write? I can write that angle 1 plus angle 2 plus angle 3 plus angle 4 is actually equal to 180 degree, and this is something that I have to prove. Okay, this is something that I really have to prove. This is what we'll be accomplishing here. So for that, the first thing I do is that I notice that these are altitudes. So this angle has to be 90 degree, which means that this angle 1 plus this angle 2 plus this angle, I am calling this angle 5, have to be equal to 90 degrees, because the sum of all the angles of a triangle is 180. One of the angles is 90 degrees, so the other angles must total 90 degree as well. So this tells me that angle 1 plus angle 2 plus angle 5 is actually equal to 90 degree. Similarly, we can also say from this triangle right here, this is 90 and this I call angle 6. From here I can say that angle 1 plus angle 2 plus angle 6 is equal to 90 degrees. This is 90, okay, in this triangle this angle is 90. So sum of this angle plus this angle plus this angle, if you will, in the triangle ABP should be equal to 90 degree as well. So I have these two equations. Now I'll use a small thing again, okay. I'll just use one small trick, if you will. And that trick is, notice that triangle, in triangle ABH, okay. So this is the triangle I am taking, A, B and H, this triangle. Notice at this H, notice something about this H. This H, or this angle 3, is the exterior angle of the triangle. And what are the two interior opposite angles? 1 and 6, which means that angle 3 is equal to angle 1 plus angle 6. Similarly, this angle 4 is equal to angle 2 plus angle 5. So angle 4 is equal to angle 2 plus angle 5. Okay. Now these 3 in this equation, right, angle 1 plus 2 plus 5, 1 and 6 can be combined together in this equation. So 1 and 6 I am combining in this equation, and what I can write? I can write angle 1 plus 1 and 6 become angle 3 is equal to 90 degree, and I use this equation. Okay, this is the equation I am using, this one, and this equation right here, 2 plus 5. So 2 plus 5 I can combine them as angle 4. So I can also write, sorry, in the first one, in this I have combined angle 1 and 6, so this should be equal to 2 plus 3, and from here I'll get angle 1 plus 2 and 5 I can combine, and I can write as angle 4 will be equal to 90 degree. So this equation and this equation. So now if I add them, or add these two equations together, I get angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to 90 plus 90, which is equal to 180 degree. So that is what we intended to prove in the first place. Okay, so again with this we have completed this theorem. This is the second theorem regarding the reflections of orthocenter. Now reflections of orthocenter are important, and if you remember these theorems, they might come in handy in solving the coordinate geometry problems or other problems that the JEE people might throw at you, JEE Advanced especially. Okay, thank you.